need to show you, and there's only one example here, which there should be another, but we'll work with what we have. You'll notice here that we have the line segment RT, and it's on the coordinate plane, where R is negative 3, 5. But in this case, we're given the midpoint. We are told that S is the midpoint, and we want to find the value or the coordinate of point T. Okay, so in this case, we're not asking for the midpoint. This is actually the opposite. We're given the midpoint and we want to find the endpoint. So here there are two ways you could solve this. Using either number lines or strictly algebra using the midpoint formula. So I'll show you first how to solve it using the midpoint, okay, formula. So of course, to find the coordinate of point T, we're looking for the second x and the second y value of our midpoint formula, which is the sum of the two x values divided by 2, comma, the sum of the two y values divided by 2. Okay. So to solve this algebraically, what we're going to do is I'm actually going to split the formula up, because of course there's an x and a y. So the m obviously is the midpoint. So the midpoint for x and the midpoint value for y. Okay. Now this is, so S is your midpoint. You'll notice the x value of your midpoint is -1 and the y value is +1. Okay. So that's what the m of x and the m of y stand for. Those are your answers from the midpoint formula. So for x, it's -1. And for y, it is +1. Okay. So from here, what we're going to do is we're going to solve this like any other algebraic equation. And because we have a fraction, the easiest thing to do is to get rid of that fraction by multiplying both sides of the equation by 2, because then that gets rid of the denominator. Okay? So these 2's will cancel, these 2's will cancel. And so what I have is -2 equals, now x1 is my r value, so that's -3. And we're solving for our x value of t, or our x2. Here for y, we're going to get 2 equals, okay, our y value is 5. We're solving for our y2, which is represented by point T. So from here, we just have a very simple one-step equation left. And we did that by multiplying both sides of the equation by 2 to get rid of that denominator. So to solve for x, I'm going to add 3 to both sides. So my x2 value is actually at +1. And then my y value is negative 5. So y2 equals negative 3. So point T that we were solving for has a coordinate of positive 1, comma, negative 3. Okay, so that is how we can solve algebraically. Now we could also solve this using number lines. Okay, so and what we do is we set up a number line for the x's, and then a number line for the y values. So let me do that. For those of you who solved fractional distances using the two number lines, this isn't extremely different. So you'll notice we have r is at negative 3. My x values, r is at negative 3, and s is at negative 1. Okay, and then my y, r begins at positive 5 and goes to 1. So r is at 5, s is at positive 1. Okay. So once you've set up your number lines and you placed your letters at the appropriate values, remember what we're trying to solve for. And the fact that S is your midpoint. So that means S is the middle of the line segment itself. Okay? So from R to S, if we count, that's going to be that has a length of 2 units. And remember my original definition for a midpoint. Midpoint cuts a segment into 2 smaller congruent pieces. So if S is in the middle and along the x-axis R is 2 units away, that means for S to truly be the midpoint, T must also be 2 units away. And so that's how, using the number line, you'll notice we got positive 1 when we solved algebraically. Now we're going to do the same exact thing for the y-axis. You'll notice from R to S is 4 units. So the fact that S is in the middle, point T must also be 4 units. So that puts T at negative 3. So that is 2 ways that you can solve for the end point of a line segment given the midpoint.